Concentrations of substances in the water, like in this bottle, like the nutrients or the iron content, can be determined analytically in the lab. However, that is quite laborious and time consuming. So we do have an alternative, which is in front of me. We do have different field kits. So we have one for ammonium, one for phosphate, one for nitrate and total hardness. We also have one for iron, but this is not on the table here. So I will demonstrate one of those field kits, for example for phosphate. Instructions are inside on a chart. And instructions are written here. So you have two tubes, you place one on A and one on B, and on B you have to add something with phosphate 1, 6 drops. Then you have to shake, add from phosphate 2, 6 drops, shake, wait 10 minutes, and then you do a comparison. The comparison is on the back side. In this case it's in blue, the scale. A is the sample without the chemicals, and B is the sample with the chemicals, and you compare the colors. If you have the same intensity, then you stop and you can read the concentrations which are listed above. For nitrate we have a similar chart with instructions on the front side and the color range on the back side. As you can see, the concentration ranges from 0 to 120. So this kit is not so very precise, but there are other field kits which are much more precise. And again, ammonium, we have the same instructions chart on this side. This is what you should do here, and on the back we have a different color chart again. Let's do one example. Let's take the phosphate. So I have a sample here, a small bottle. We have a tube holder. We have two tubes. They are closed with a lid. Remove the lid. Take your sample, and the first thing is that you should wash the tubes. This procedure should be repeated 3 times. So now we washed the tubes. We look at the chart, and first we should add 5 milliliter of sample, both in A and in B. Do it differently. There's a mark on the tube here which stated 5 ml. Then over here it states that from phosphate 1 we should do nothing in the A, and we should put 6 drops in B. Usually I take off the bottle and we just count the drops. 3, 4, 5, 6. We should mix it thoroughly like this. 10 to 15 seconds. We take phosphate 2, add 6 drops again. 1, 2, 3, 4, 5. So that was number 6. Close it. Shake again. 10 to 15 seconds. We close them both, then no substances can fall in it. Then we have to wait for 10 minutes. So the 10 minutes are over now. Switch the card. As you can see, I hope, on the white table, this one was the sample without addition of the substances, and this was with the chemicals. And now we have to compare. So why do we take a blank with us? You could argue that looking like this, so without the A sample, would be sufficient to determine the amount of phosphate in this case. But that might be the truth when your sample is really clean very clear like this, but if there's a slightly colored sample, then your blank is correcting for the color of the water. So always take the blank with you. You start at 0 and you move to the right until you think, well, this color matches exactly what I'm seeing. We start here at the start position and slightly move from 0, add a little bit more. So I think this one is still not corresponding. This one is also not corresponding. You see that on top the A becomes more and more bluish. And here I doubt already a little bit, but maybe the reference is still too light. I think this could be a nice color. So this is around 1. You can see here with my finger on the top. Then we go to the 2, and I think 2 is already too dark. At least 3 is too dark. I think 2 is also too dark. And 1 is too light. So it's between 1 and 2 milligram phosphate per liter, expressed as phosphorus. So that's indicated by this P behind the PO4. So in this sample we had 1.5 milligram per liter phosphorus. Once you're finished, please throw the sample with the substances in a special bin for the garbage. Wash your tubes again and store everything correctly. Instruction for the hardness kit is slightly different. So we can open it. We have the chart here, and it's indicating that you should put in 5 milliliter of your sample, then 3 dots of H1, then it seems to become red, then you use H2 and you add H2 while shaking, and then the color should change to green. Wash the tube with the sample 3 times, then we put 5 ml in it. We take the H1, 3 dots, 3. You see the color is green. If you shake, it's becoming red. Then you take the H2, you turn off the lid, switch, turn it on like this one, the sirens. It has 2 sides, so we scale from 0 to 20 in German degrees, and on the other side you have a scale from 0 to 350 milligrams per liter calcium carbonate. Put the sirens at the stop on the bottle, carefully lift it on top, adjust it exactly to the 0, remove it, there's no liquid in this part of the tube, but it's all in the lower part. Shake the sample a little bit and add it drop by drop. 1, counting, 3. So sometimes it's really difficult if you're right-handed, then you can switch. Then it has to become green. This is still red. Now you see a slightly change in the color already. So after 1 drip, it immediately switches from red to green. If there is still material left in this tube, you can put it back. You can see the scale here. It is around 7, so 7 degrees German hardness, corresponding to, let me see, 125 approximately milligram calcium carbonate per liter. Release the liquid you have and close it again.